Hello, fifth graders. I realized that today I was asking for a lot of review, and some of us might have needed a little bit more of a video or some instruction to go with it. So I thought that it would be best if I made a little video today to go over some of the things that we are going to need for when we come back in school. So it says, I can add and subtract fractions with unlike denominators. So the key word there is unlike. That means the denominators are not going to be the same. And I'm going to kind of show a couple different things so that we can see what we're going to be doing when we come back and what skills we need to review for when we get there. So, oh, I don't know why that's still there, but so when we get back, we are going to be solving problems like the ones you see on the screen. 2/3 plus 1/2, and what does that equal? And then 2/3 minus 1/6. So before we can do adding and subtracting of numbers with unlike denominators or denominators that are not the same, we're going to go back and we're going to review the ones that, some things that we do need to know. So the first thing is that you need to know how to add and subtract fractions that might have the same denominator. And I'm going to try my best to kind of see how I can do this. So I am going to show you with some fraction strips. I'm going to come over here and we're going to review the problem 3/4 plus 2/4. As you can see, both of these are fourths. So we are adding fourths to fourths. I'm going to show you a visual model so you can remember what we're seeing. So first I need 3/4. So I'm going to pull my fourths. I have 1, 2, 3. And I am going to add 2/4 to it. So I need 2 more fourths. They are still 4 same size pieces. So I'm going to say 1/4, 2/4. And I'm going to label this so you can see that this is my 3/4. And then I've added 2 more fourths. But the pieces did not change because they are 4s and 4s. And what would that equal? Well, the first thing you could do is we could count 1/4, 2/4, 3/4, 4/4, 5/4. When we have our visual models, now please do not get on me because I know my hand is shaky. I'm drawing with my mouse, which is not easy for me. So when you look at this, we know 5/4. We know because we were able to see this. Now I know you don't have fraction tiles at home, and if you were looking up here, you would say, oh, well, since I was dealing with 3 and 2 more, put those together, they were 5. Those pieces stayed the same. They were forced no matter what. Now, the thing I'm going to say is 5/4. Now, what does that equal? Well, we know that this is a fraction greater than 1 whole because our whole is made out of 4 pieces and we have more than that many. So I'm going to pull my whole out here. Let me get my... When I line this up, you can see that those 4/4 equals 1 whole, and there is 1/4 more. So if you were going to write this as a mixed number, we know we have 1 whole, and that 1 whole stops here, and there is 1/4 more. For purposes, it is okay if you are still leaving your fractions as fractions greater than 1, but remember, we need to start thinking of what does that mean? What does that actually mean? Miss G ate 3/4 of a pizza on Monday, 2/4 of another one, or 2/4 more pizza on Tuesday. How much pizza did I eat? Well, I ate 5/4 of a pizza, so you're going to have to know that I had to order 2 pizzas. 2 whole pizzas because I needed more than that 1 whole pizza to get there. Now, I am struggling because all of these buttons are in my way. But I'm going to hopefully clear this. Gotta get this back. I want to restart. And Oh no. I'm going to erase it all. I wasn't using the right tools to show you all that. But when we add fractions with the same denominator, we are going to make, if the denominator is the same, we can just add the numerators. So let's practice one together on this screen. Let's say we have 2/5 plus 4/5. If my denominators are the same, I'm dealing with the same size pieces, I can put these pieces together. So I'm going to add my numerators. 2 plus 4 is 6. My denominator will stay the same. 6/5 is the correct answer. Now, the only difference is that this is greater than 1 whole. How many pieces are in the whole? 5, because our denominator tells us that. So if I have 6, that means I have 1 whole and 1 more piece, or 1 out of 5 more. So that would be that as a mixed number. I do not want to do that. So remember, adding fractions with the same denominator, the denominator stays the same, and then you add the numerators. Now, let's look at how we would have to do this if we were subtracting. So for subtraction, it's the same thing, but you have to think about taking those pieces away. So I'm going to go back to my fraction strips to show you one. If I had 1 and 2/5, and I want to take away 3/5. Well, if you're looking at this, we might say, oh, well, I have 1 whole and 2/5, and I'm taking away 3/5. I just told you to subtract the numerators. 2 minus 3. Well, we don't have enough pieces to take 3 away because we only right now have those 2 pieces. So, but we actually have this 1 whole. So let's go back and build this out. So if I have 1 and 2/5, so I have 1 whole and 2/5, and I need to take away 3/5. There's 1/5, 2/5. I have more to take 1 more fifth away, but I'm going to need to break this whole into pieces. Well, how many fifths are in a whole? 1, 2/5, 3/5, 4/5, 5/5. Now I have another piece to take away, and since this was traded in, I don't really want to do that. What do I have left? I have these 4/5 pieces left. So this is a little bit different, and it does take us to go back and remember, but just like normal subtraction, when you do not have enough of one place value, you have to go to the next place value. So remember, fractions are just part of our place value system. If you don't have enough of the pieces, you're going to get more pieces from going to your whole number and breaking it into pieces. How many pieces will you get? Well, you have to pay attention to the denominator. So you have to know how to add and subtract fractions with the same denominator before we can go back and do unlike denominators. Now, if you look at these problems, I cannot solve these problems the way they are because just like I just told you, I also need to add and subtract fractions with the same denominator. So if you look at these problems, they don't have the same denominator. So the next thing you would have to be able to do is, well, how can we make equivalent fractions? How can we make their denominators the same? So I'm going to take you back to the fraction strips again so that we can see that visual model. I'm going to reset my workplace. Okay. If I was trying to find the equivalent fraction of 2/3 equals blank 6. So I know that I'm starting with 2/6 and I'm going to turn it 2/3 and I'm going to turn it into 6. So let's get our 2/3 out. 1/3, 2/3. And I want to turn these into 6. Well, if you get your 6 out, you will notice that for every third, it takes a group of 2. 6. So if it's going to take a group of 2, that means we're going to have 2 times as many. 3 times 2 equals 6. And if we are getting 2 pieces for every one of our thirds, that means that our numerator will also double, and we will get 2 for that third and 2 for this third. And so we will have 2 pieces for each third, which will give us 4, 6. Now, you will notice that we are doing the same thing to the numerator and the denominator. That's because we are creating these equal groups. 1/3 is made up of 2 pieces. So since we have 2/3, this would be 2 pieces and this would be 2 pieces. So we are creating those equivalent fractions. Now, this is a lot for us to review online, but let's take it back to where we're going to go. When we get back to school, you will notice that we have 2/3 plus 1/2. We cannot add this because the denominators are not the same. So we're going to have to figure out what denominator can both of these numbers have that would be the same. How would 3 and 2 get same denominators? We can use our fraction strips to think about this, or you can start thinking of common multiples. So if we skip count by 3s, we would say 3, 6, 9. If we skip count by 2s, 2, 4, 6, 8. Notice that when both of these will have a multiple of 6. So they can have a common denominator of 6. We can change thirds into 6, and we can change halves into 6. We are doing these 2 problems when we come back, so I just wanted to give you a little preview. I'm now going to show you what your NTI work is for today. It says, find the value of each expression, explain or show your reasoning. So I have given you some practice problems of adding fractions, and I've given one subtraction one as a challenge with the same denominator. Okay, so even though this 2 is a whole, 2 wholes, what size pieces would you break it into? Well, look at the denominator. It's 8. So how many eighths are in a whole? These are fifths and thirds. Remember, numerator plus numerator, the denominator stays the same. Over here, I want you to practice your equivalent fractions. How would you change thirds into sixes or sixths? How many sixths make up a third? How would you change fourths into twelfths? Remember, these pieces are the same. So if you had a pizza and you had them cut into fourths and more people showed up and you need to feed 12 people, what are you going to do to each of those fourths to make them equivalent for everyone to have a fair share amount? I hope this is helpful. I hope we're back in school soon. If you have any questions, please reach out. Bye.